Hi hello everyone. For this session I will discuss exercise 8C problems. So see your first one. Limit x tends to pi by 2 cos x divided by x minus pi by 2. Okay. So see here, you know that limit x tends to 0, sin x by x value is equals to 1. So this is the limit formula. Okay. But here cos x is there. So we have to change this cos x into sin. So how to write cos x? See here, cos x can be written as sin of 90 minus x. Okay. See here. So see here, this is limit. Send pi by 2 left, then you get x minus pi by 2 tends to 0. How to write cos x? Sin of pi by 2 minus x. Sin of pi by 2 minus x. So divide by x minus pi by 2. So once you observe here formula, limit x tends to 0, sin x by x is equals to 1. So here these all terms are equal. X. Here x minus pi by 2, x minus pi by 2. But here pi by 2 minus x is there. So clearly we have to change into x minus pi by 2. So see here, this is limit x minus pi by 2 tends to 0. So your minus is common. You will get sin of minus x minus pi by 2. So divide by x minus pi by 2. So again this is limit x minus pi by 2 tends to 0. So sin of minus theta. You will get minus and theta. So write minus outside the limit. So this is sin of x minus pi by 2 divided by x minus pi by 2. So clear it in the form of limit x tends to 0, sin x by x. So clear this value is 1. So this is equals to minus 1. So this is the required answer. Okay. So see a second one. Limit x tends to 0, sin ax by x cos x. Okay. So see here this can be written as limit x tends to 0 into sin ax by x into 1 by cos x. Okay. And apply limit for first and second. So this is limit x tends to 0, sin ax by x, and this one into limit x tends to 0, 1 by cos x. Okay. So here we know that limit x tends to 0, sin ax by x value is a. Okay. So clearly coefficient of x is what? A. So answer is a. If in place of a, k is there, sin kx by x, so answer is k. Okay. So clearly this value is what? A into 1 by, apply limit here, cos 0. So cos 0 value is 1. So a into 1 we get a. So this is the required answer. So see the third solution. Limit x tends to 1, sin of x minus 1 by x square minus 1. Okay. See here, denominator is x square minus 1 square. So it in the form of a square minus b square. So see here, this is limit x tends to 1, sin of x minus 1 by x minus 1 into x plus 1. See here again this can be written as limit x tends to 1, sin of x minus 1 by x minus 1 into 1 by x plus 1. And apply limit for this term and this term. This is limit x tends to 1 sine of x minus 1 by x minus 1 into limit x tends to 1 by x plus 1. So clearly it in the form of limit x tends to 0 sine x by x. So value is 1 into apply limit here 1 by 1 plus 2. We will get 1 by 2. This is the required answer. See here question number 4. Limit x tends to 0 sine of a plus bx minus sine of a minus bx divided by x. So it in the form of sin c minus sin d. See here, you know that sin c minus sin d form 2 cos c plus d by 2 sin c minus d by 2. So this is sin c minus sin d form. So clearly c is a plus bx and d is a minus bx. So replace c and d by a plus bx and a minus bx. So this is limit x tends to 0 2 cos. So add these two c plus d. C a plus bx plus a minus bx. So bx get cancelled. So you will get a plus a. So 2a by 2. Next sin c minus d. So subtract these two. See here a plus bx minus of a minus bx. So plus a minus a get cancelled. Bx plus bx, you will get 2bx. So 2bx by 2. Okay. So divide by what? X. So 2 get cancelled. So clearly 2 cos a is the constant. So write constants outside the limit. So 2 cos a into limit x tends to 0. Here 2 get cancelled, will get sin bx by x. So this is 2 cos a into 2. See here clearly quotient of x is b. So write this answer is b. So therefore this is equals to 2b cos a. So this is the required answer. So next question number 5. Limit x tends to a tan of x minus a by x square minus a square. Okay. So this can be written as limit x tends to a tan of x minus a divided by. So denominator in the form of a square minus b square. This can be written as x minus a into x plus a. So again this can be written as limit x tends to a tan of x minus a by x minus a into 1 by x plus a. And apply limit for separate. This is limit x tends to a tan of x minus a by x minus a into limit x tends to a 1 by x plus a. So clearly it in the form of tan theta by theta. See here you know that limit x tends to 0 tan theta by theta line is equals to 1. So clearly in the form of tan theta by theta. So this value is 1. So apply limit here 1 by a plus a is equals to 1 by 2. This is the required answer. See here question number 6. Limit x tends to 0 e power 3 plus x minus e power 3 by x. See here limit x tends to 0 e power 3 plus x, write as e power 3 into e power x minus e power 3 by x. So clearly in numerator e power 3 is common. This is limit x tends to 0 e power 3 is common, you will get e power x minus 1 by x. So e power 3 constant outside the limit. So e power 3 into limit x tends to 0, e power x minus 1 by x. So clearly this formula is 1. So this is equals to e power 3 into, so this answer is 1. This is equal to e power 3. So this is the required answer. So see our next question number 7. Limit x tends to 0, e power sin x minus 1 by x. Okay. So see here, you know that limit x tends to 0, e power x minus 1 by x formula is 1. But here sin x is there. So e power sin x. So clearly in place of x, sin x is there. So for that, you want to multiply and divide with sin x. So because of in denominator you want sin x. See here, this is limit x tends to 0, e power sin x minus 1 by x. See here, multiply and divide with sin x. So this can be written as limit x tends to 0, e power sin x minus 1 by sin x into limit x tends to 0. So apply limit for sin x by x. Sin x by x. So clearly in the power of e power x minus 1 by x. So this answer is 1. And this answer also 1. So clearly value is 1. See our next question number 8. Limit x tends to 0, root 1 plus x minus 1 by x. Okay. See here, one method is there. If root is present, then we have to do the rationalize in the limits. See here, clearly rationalize. That means root 1 plus x plus 1 by root 1 plus x plus 1. We have to multiply and divide with root 1 plus x plus 1. Now this is limit x tends to 0. So numerator in the form of a minus b into a plus b. This can be written as a square minus b square. So root 1 plus x whole square minus 1 square. So divided by denominator is x into root 1 plus x plus 1. Okay. Now this is limit x tends to 0. Here square root get cancelled. 1 plus x minus 1 by x into root 1 plus x plus 1. So clearly plus 1 minus 1 get cancelled. X get cancelled. This is limit x tends to 0. 1 by root 1 plus x plus 1. Now apply the limit here. You will get 1 by root 1 plus 0 plus 1. So this is 1 by 1 plus 1 is 1. So this is the required answer. So see here question number 9. Limit x tends to 0, e power x minus 1 by root 1 plus x minus 1. So clearly this problem also involved root. So clearly in that case we have to do the rationalize. See here, clearly multiply and divide with root 1 plus x plus 1 divided by root 1 plus x plus 1. Now this is limit x tends to 0, e power x minus 1 into root 1 plus x plus 1 divided by, so denominator in the form of a minus b into a plus b. So this is root 1 plus x whole square minus 1 square. So square root get cancelled. This is limit x tends to 0, e power x minus 1 into root 1 plus x plus 1 divided by 1 plus x minus 1. So 1 get cancelled. Now this is limit x tends to 0, e power x minus 1 by x. So write this one, e power x minus 1 by x, and apply limit for this second term. Limit x tends to 0, root 1 plus x plus 1. So clearly this answer is 1. And this one apply limit root 1 plus 0 plus 1. You will get 1 plus 1 is 2. So this is the required answer. Here question number 10. Limit x tends to 0 a power x minus 1 by b power x minus 1. Okay. So here you know that limit x tends to 0 a power x minus 1 by x value is log a. Okay. Now, but here numerator is a power x minus 1, denominator is b power x minus 1. So here you want x. So for that, both numerator and denominator divide with x. So here limit x tends to 0, a power x minus 1 by x divided by b power x minus 1 by x. So apply limit for both numerator and denominator. This is limit x tends to 0, a power x minus 1 by x divided by limit x tends to 0, b power x minus 1 by x. So clear what is this formula? Log a. This is log a divided by, so in place of a, b is there. So this is log b. So log a by log b. So this is log a to the base b. So this is the required answer. So try to solve question number 11. Okay. See question number 12. Limit x tends to 0 e power x minus sin x minus 1 by x. See here this can be written as limit x tends to 0. So write first and last term first. That is e power x minus 1 minus sin x divided by x. See here separate the terms here. Limit x tends to 0 e power x minus 1 by x minus sin x by x. So apply the limit for two terms. This is limit x tends to 0 e power x minus 1 by x minus limit x tends to 0 sin x by x. So clear these two are the formulas. This value is 1 and this value also 1. So 1 minus 1 is 0. So this is the required answer. See here question number 13. Limit x tends to 1 log x by x minus 1. Okay. See here you know that limit x tends to 0 log of 1 plus x by x. This value is 1. See here but numerator is only log x. Denominator is what? X minus 1. But here denominator is x only. So for that put x minus 1 is equals to y. From this what is x value? Y plus 1. Okay. Now this can be written as limit x minus 1 tends to 0. So one side left you will get x minus 1 and log x by x minus 1. So this is limit, what is x minus 1? Y. So limit y tends to 0. So what is x value? Y plus 1. So log of y plus 1 by x minus 1 value is y. So clearly it is in the form of limit x tends to 0 log of 1 plus x by x. So clear this value is 1. So this is the required answer. For next session we will discuss more problems.